So my name is Drew Berry, and I am a specialist biomedical animator. And what that means is I translate scientific discovery, scientific information, into a visual story that you can watch in action. I started my career as a cell biologist, but also as a teenager, wasting my summers playing around with computer games and computer graphics. And I've created a career where I combine my passion for science, for cell biology and molecular biology, and using computer graphics to reconstruct what we've discovered and making it into animation, into visualizations that people can watch and just intuitively understand the mind-boggling things we're discovering about how our cells and tissues work. For the Chemistry of Life project, I was responsible for creating molecular visualizations that show how our cells create energy, the molecular mechanisms of how our cells create energy, as well as how plant cells use sunlight and capture sunlight to create the food and oxygen that we need to eat and stay alive and to breathe. So to understand how we work and how our cells come to be alive, the chemistry of how our cells come to be alive, it all happens at an extremely small scale and extremely fast speeds that we can't even imagine. And to see it in action, it really requires us to transform that into an animation, into a visualization that people can watch in action. So I am translating and transforming real scientific data and putting it into a format that everyone can watch. And just by seeing it in action, you can really get a sense of how it works. We are in a tremendous revolution right now of tremendous discovery of how our cells work and how life on Earth comes to be alive. And so there's a tremendous need for us to transform that into a visualization that the general public can watch. And so scientists can convey and explain how it is, what they're discovering, and just the wonderful mechanisms that are mind-boggling. So the visualizations I created for Chemistry of Life are all they're all made from real scientific data, and they are representing what is described in the scientific literature, what the scientists are actually discovering, but they have to be transformed into a format that is meaningful for the general public and for students to see in action. So it's all real scientific data. Molecules, though, are very, very small, and we can't directly observe them because they're smaller than the wavelength of visible light. They're smaller than most of the technologies we have for microscopes. But we do have lots of very good data, very good information about how molecules work, their shapes, their forms. So we have a lot of great scientific data, very, very precise scientific data, so we have a very good understanding of what's happening at the molecular scale, but we don't have any direct way of observing it and seeing it. So my job is to take all of that very specific, the measurements, the 3D structures of the molecules or the enzymes of the proteins, and transforming it into a way, combining it, and presenting it in a way that the general public can watch, that students can watch and see it in action. The Chemistry of Life production was really a tremendous challenge, technical challenge, not only for bringing together many forms of data and creating a visualization of that, but then presenting it in a giant scale on the dome. It requires the most advanced technology we have today to access scientific data and to make it watchable and visible, but then to craft it in such a way that it's meaningful and is an exciting journey that students and the public can experience on the dome. It really was, for me, the hardest project I've ever worked on. I've been working on creating visualizations for 30 years now, and nothing came anywhere close to what we had to do for this dome. But what a tremendous and exciting challenge it was. I delighted and really enjoyed accessing the scientific data and having my mind just blown by how incredible it is what we're discovering. But then to put it in such a format that it becomes just a cinematic, wonderful journey that people can enjoy as like a roller coaster ride through this data. So it was really the pinnacle of my career that I've ever had to the technical challenges, the storytelling challenges, and just to be able to transform real scientific data into something that was meaningful and that somebody could watch in action. For me, having worked in scientific discovery for 30 years, I get very excited. My mind is blown about how it is that we work at the molecular scale, how it is that we come to be alive. And I hope that the Chemistry of Life film brings that to wide audiences all across Sweden at the Wisdom theaters and science centers, that students and the public can really get excited and get inspired about how we work at the molecular scale.